Welcome everyone. In this video lecture, we will solve a GATE 2003 EC question which is based on the output of the comparator with duty cycle. So basically we have to find the duty cycle. So the question is, if the input of an ideal comparator shown in the figure is a sinusoidal signal of 8 volt. So here the input we are giving 8 volt peak to peak sinusoidal signal without any DC component, then the output of the comparator has a duty cycle. Option A 1 by 2, option B 1 by 3, 1 by 6, option D 2 by 3. So before that we have to go for the very simple basic concept about the comparator operation. So I am writing here how comparator works. Okay. So as we know, the very fundamental concept, non-inverting input, inverting input, and this one is the output. Okay, I am saying this is a V plus and this one is our V minus. So there are the possibility. So if this V plus is greater than V minus and it is open loop, so the output voltage, say this V naught will be plus VCC. Okay, and when V minus is greater than V plus, then the V naught will be minus VCC. Okay, here I am just giving plus VCC and minus VCC. So this one is the fundamental of a comparator. Means if the V plus, that is inverting input, is greater than non-inverting input is greater than inverting, so plus VCC. And when inverting one is greater than non-inverting, so it should be minus VCC. Okay, so this one is the concept. So now we have to move for this question. So in this question, it is given the input is given sinusoidal signal with 8 volt peak to peak. So what it means? For this purpose, what we are doing, 8 volt peak to peak. Okay, means the somehow like this. Say some sinusoidal signal is there. Say with omega t and say V input. I am writing this as I am saying V input. Okay, and it is given 8 volt peak to peak. So this V in is nothing but simply 4 times of sine omega t, because portion the upper portion is our 4 volt. Okay, and this one is our minus 4 volt. So total this will be 8 volt. Okay, 8 volt peak to peak. So this, that's why we are writing 4 sine omega t. This one is the input at the non-inverting side, or this one is our V plus, and there is one more voltage, that is our V there, that is our V minus. We can write this as a V minus. Okay, and this one is nothing but simply our V plus. We can write like this. Okay, so the another way input, that is our V minus. Here I'm writing V minus is equal to V there is equal to 2 volts. So a line which is parallel to this. Okay, so I am saying this line is our V there equals to 2 volt. 2 volt, or simply our this one is your V minus. Okay, this one is also, we can say this one is V minus 2 volt, anything. Okay, now we have to do the comparator operation. So as we see from the graph that above this line, above 2 volt line, okay, means V ref equals to 2 volt above this line. Okay, above this line it should be, the V plus will be positive. So V plus, or we can simply say the V input is greater than the V ref. Okay, means what I am saying, In this portion, this will be positive, this will be positive above this line. Okay, above this line it is positive. Okay, one more thing means above this line. Okay, this line, this one will be positive. Okay, so the output value, so the output value we can directly write for this case v naught equals to what, vcc, or simply say right plus vcc. Now if, and below this, okay, below this line, below this line, okay, below this line, the v naught value will be minus vcc. Okay, v there 2 volt below this line. Okay, one line is there above this line, this one. Okay, I am highlighting this one. Okay, and below this line v naught equals to minus vcc, because the vi minus will be more. Okay, means here vref will be 2 volt, but here it should be 1.5 or 1 volt, like this, yes or no? Means, okay, so now again I am redoing the output response for this circuit. So this one is omega t, and then this one is our v naught. So one point will be there. Okay, so now we can easily say that what is the point. Okay, so here we can say the 4 sine omega t equals to 2. Okay, this point of intersection. Okay, this point of intersection equals to 2. So sine omega t equals to 2 by 4, so it should be 1 by 2. Okay, so omega t will be 30 degree. Okay, sine inverse 1 by t 30 degree, or simply we can say pi by 6. Okay, so this point now we know pi by 6. So the next point will be pi minus pi by 6. So this point will be 5 pi by 6. Okay, similarly this point will be 2 pi plus pi by 6. Okay, so again, okay, okay, so if we draw the output curve, it is plus vcc. Okay, in this range. Okay, and below this it will go like this. Okay, so this point is pi by 6, pi by 6. So this point will be our 2 pi plus pi by 6. So this point will be 2 pi plus pi by 6. Okay, so this one is the output response of a that comparator, and this will be our plus vcc and minus vcc. Okay, so now what we have to do, this one is, we can say the t on, and this should be our t off. Okay, and the duty cycle we have to find. So it is nothing but simply t on by t on plus t off. Okay, so t on means in which interval it is t on. So this should be our 5 pi by 6 minus pi by 6. Okay, this is the range. Okay, 5 pi by 6 minus pi by 6 by the total period t on plus t off, this to this distance. So this to this distance is nothing but simply 2 pi plus pi by 6 total up to this point minus this minus pi by 6, or simply this should be our period, so it should be the numerator should be 4 pi by 6, and this one t on plus t off will be 2 pi. So that can be easily observed from 2 pi by plus pi by 6. Okay, this one is our t off, this one is our t off. Okay, so it should be 4 pi by 6 into 2 pi, so it should be 2 here, then 2 by 6, it should be our 1 by 3. So duty cycle will be 1 by 3. So main thing is we have to draw this output. Okay, and the duty cycle formula T1 by T1 plus T0. Then we can easily draw the waveform first for when the input is V plus is greater than V minus. So it should give the plus VCC, and below this one it will give minus VCC. So this one is the important concept. So then after we can find the duty cycle. So we have to observe what should be this point pi by 6, pi minus pi by 6, so 5 pi by 6. Okay, so we are not interested in this one, so this would be again 2 pi plus pi by 6. Okay, this point. So up to this one, so this one is the total period. So this one is our t total period, that is our 2 pi. So directly we can write 2 pi also, but 2 pi plus pi by 6 minus pi by 6. So this one is the total period. So after solving, it will give the value, that is our 1 by 3. So this one is also important formula, T1 by T1 plus T of. So the final answer for this uh, question will be 1 by 3. So this is all about this question. So the simple thing is that we have to know the basic concept of comparator and how to draw the graph. Okay, then after we have to draw the final output curve. Okay, and then we can easily say T1 by T1 plus T of. So this is all about this question. So thank you for watching this video.